Hi, I'm Ian Kirby, and today I'm going to be teaching you about acid nomenclature. But before we talk about acid nomenclature, let's review the key aspects of an acid. So a general definition of an acid is a molecular compound that dissociates in solution. It also releases H+ ions when dissolved in water. These H+ ions can be interchangeable with protons, but that doesn't really matter right now. One physical property of acids is that they taste very sour. Lastly, they can be categorized into two types of acids, binary acids or oxyacids. So without further ado, let's get into the nomenclature. Binary acids are the first category that an acid can be placed in. They are made up of hydrogen and a nonmetal. But how exactly do you name a binary acid? Well, there's a very simple formula to do so. The first thing you should do is take the prefix hydro. Then you add the base word of the nonmetal. Keep in mind that the nonmetal will usually end with "ide". Then you add "ic", and then you add the word acid at the end. An example of this is hydrochloric acid. First you start out with the prefix hydro. Then you have chlor, as in the root word of chlorine or chloride. Then you add "ic", and then you end it with acid to get hydrochloric acid. Binary acids only contain two elements, so let's talk about oxyacids, which contain more. Oxyacids are very similar to binary acids, as in both contain hydrogen. However, instead of a nonmetal, oxyacids contain an oxyanion. An oxyanion is an anion that contains both a nonmetal and oxygen. The oxyanion is the most important part of the oxyacid, as the oxyanion ending dictates how you will name the oxyacid. So naming oxyacids is a little more complicated than naming binary acids, but they both follow generally the same formula. Unlike with binary acids, you completely disregard hydro as the prefix. Instead, you start with the base name of the oxyanion. Now's where it gets a little complicated. If the oxyanion has the ending "ate", you would have to add "ic" to the base name of the oxyanion. If it has the ending "ite", then you would add "us" to the base name of the oxyanion. After that, you would add the word acid. Sulfuric acid is a good example of an oxyacid. In its case, you would take the base name of the oxyanion sulfate, sulfur, and you would add "ic" due to the ending of "ate". Then you would add acid to get sulfuric acid. If instead we were using sulfite, all we'd have to do is change the "ic" to "us" because of the ending of "ite", and that would give us sulfurous acid. One last thing is that the number of hydrogen ions depends on the charge of the oxyanion. The acid must always have a neutral charge, so the amount of hydrogen ions and the charge of the oxyanion have to cancel each other out. Something worth noting regarding binary acids is the use of the prefix hydro. This is used basically to relate to the fact that hydrogen ions are being donated. I just thought it was a cool fact to mention. With all that being said, thanks for watching my video. I hope you learned how to name binary acids, oxyacids, and in general, I hope you enjoyed learning about acid nomenclature.